Hi guys, our video today is solving systems of equations by graphing. This is the first method for solving system of equations that we'll take a look at in this unit. The first thing that we need to know is what is a system of equations. A system of equations is when we have more than one line graphed on the same coordinate plane. The solution is where the lines intersect, so that's going to be very, very important here. When we were looking at quadratics, we knew what the solution was. When we're looking at systems of equations, the solution is where the lines intersect, and you're always going to give me that answer as an ordered pair. So what you need to do is in your notes is copy down this table. If the graph looks like this, so we have two lines, we can see that they intersect at one point, so there's one solution. If we graph two lines and they lie on top of each other, like you see here, so it looks like there's actually only one line, then there are infinitely many solutions. Because if you put two lines right on top of each other, they're going to cross infinitely many times. The last thing that we have are two lines that are parallel. We know that parallel lines don't cross, so that there are no solutions. So you should be able to look at any two equations I give you and quickly be able to tell me, is there one solution, infinitely many solutions, or no solutions? We're going to be taking a look at a couple of examples. I'm going to be actually using a software on my computer to graph these. You will be graphing these using your TI-84 graphing calculator. You have those steps that were given to you in class. So for our first example, we are going to look at 2x minus y equals 4 and y equals 1/3 x plus 1. Since we're using our graphing calculator, we know that in order to graph functions, they have to be in y equals. So if you look at this second equation, that's already in y equals, so that equation is good to go. However, if you look at the first equation, you'll notice that the y is not by itself. So I'm going to give you just a minute to go ahead and solve this first equation for y. You'll notice what I did is that I subtracted the 2x from both sides. So I got negative y equals negative 2x plus 4. And then since we want y and not negative y, I divided everything by negative 1 and got y equals 2x minus 4. So just double check your work, make sure that you got the same thing. So now we're going to be looking at the two equations, y equals 2x minus 4, and then the 1/3 x plus 1. So I'm going to go to my graphing software, and it says to put one equation in y1, one equation in y2. So I'm going to type in my y1, the first one, which is 2x minus 4, and then in my second one, we are going to do the 1/3 x plus 1. And you will see here that I have the graph on the screen. Now, remember the solution to a system of equations is where these two lines intersect. So first of all, I can tell that these lines do intersect and they intersect at one point. I can actually click on the intersection and it will tell me that these two lines intersect at the point 3, 2. On your calculator, you'll have to actually go through the steps in order to actually calculate that intersection. So when we go to write our answer, we are just going to say that there is one solution, and that solution is at the point 3, 2. Remember, you can go back through this example and you can pause it and rewatch it to help you. All right, let's take a look at our second example. Here we have y equals negative 2/3 x plus 1, and we have 2x plus 3y equals 9. The first equation is good to go because it's already y equals. The second equation is not. So I want you to take that equation and go ahead and get the y by itself. So here you see the first thing I did was got the 3y by itself. So that gave me negative 2x plus 9, and then I divided everything by 3. So now the equation that we're going to be looking at is negative 2/3 x plus 3. Now that the y's are by itself in both the equations, we're good to go ahead and put it in the calculator. So I'm going to delete out the equations that I have in there, And we're going to do negative 2/3 x plus 1, and then negative 2/3 x plus 3. Alright, then we're going to take a look at these two lines. So we have these two lines here. Remember, the solution is where the lines intersect. So the first thing that we need to determine is, do these lines intersect? As you can see, these lines are parallel. So since they're parallel, they're not going to intersect. So we are going to write out our solution, and we're going to say that there's no solution because the lines are parallel. So the first example, we saw where it intersected once and gave us an ordered pair. Example 2 shows us what it will look like when there's no solution because the lines are parallel. And then we're going to take a look at our third example. So for the third example, we're going to look at y equals negative 2x plus 3. And we're going to look at 4x plus 2y equals 6. So remember, what we have to do is we have to get the y by itself in order to be able to graph it. So for the second equation, I went ahead and subtracted the 4x from both sides and then divided by 2. So take a moment to make sure that you can solve that second equation. You should get the same thing that I got down here. So you should have y equals negative 2x plus 3. Once you have that, we're going to go back to our graph. I'm going to clear out what we already had in there. In y1, we're going to do negative 2x plus 3. Plus 3. And in our other one, we're going to do negative 2x plus 3. Now, you'll notice that they're the same exact equations, first of all, once we solve them both for y. And when we graph them, they overlap. So they're just two lines on top of each other. So if you have two lines put on top of each other, that means that they're going to intersect infinitely many times. So when we go to write our solution, we are just going to say that there are infinitely many solutions since they are the same line. I will use in class infinitely many solutions. Other sources will use many solutions. You'll see infinitely many. There's many different ways that you'll see that written. So that's our third example. What I'm going to leave you with are 3 examples or 3 more problems for you to try and bring to class tomorrow. For each of these, I would like you to solve them by graphing. In your notes, I would like you to have a sketch of the graph, and I would like you to write the solution.